Okay, thanks, Alastra. Nice to see you again. Good afternoon, everyone. I'm Florian Fan from AntGroup. Now is TuGraph open source head. Today, I want to share the topic about AntGroup GraphRAG, which focus on the graph AI technology advancement on TuGraph. My talk will split it into four parts. First one, I want to begin with the graph AI, the technological landscape within. In the first, I want to share the advantages of graph I think in the several years of my working on graph computing in AntGraph. The first one is the graph is the most complex data structure in the computer science, and it's suitable to modeling the real world, which means universal interconnection. Oh, sorry. Interconnection of things. And the third one is the certainty of relationships. Yeah, and then the last one is the interpretability of graph features.
Sorry, Florian, you just changed your PowerPoint to the presenter view. We were seeing the correct view originally.
Oh, sorry, I want to, let me change it. Is that okay?
Now it's good, thank you.
Okay. Oh, sorry. Okay, I will be continue. And the second part, I want to share the three paradigms paradigms of AI. The first one is we know is the symbolism, which is built on the abstract and the logical thinking, and it get intelligence from the artificial method. The typical system is about is like some expert systems decision tree, or as we know in the deep blue computer. Okay, and it's good at interpretable, but its scale is limited. Okay, the second one is connectionism, which built on concrete or bionic thinking. It get intelligence by learning. Typical system is like, as we know, is neural network, language models. It follows the second law, but have hallucinations. And the last one is behavioralism, which build on perception and evolution thinkings. It get intelligence from the by feedback from the environment. The typical technology is reinforcement learning. Okay, as we know, the hallucination is a big problem of connectionism. So we have two methods to decrease to reduce this problem. One way is symbolism, and the other way is behaviorism. So the first method may use a GraphRAG or KAG, which proposed by AntGroup knowledge graph teams. And the other way, as we know, is AlphaGo to combine the reinforcement learning with neural network. And today, the agent systems or multi-agent systems is also in this field. Okay, I want to share a general QA formula which combines the technology go together, like LLM, fine-tuning, IAG, and other like agents and also and so on. So one user to propose a question to the AI systems, the question may flow from the promote. We use promote engineering to enhance the question context, and then give the promote to combine the knowledge docs from the knowledge base through retrieval to combine a full context and the question and send this request to the LM. So the GraphRAG in this scope is, in my opinion, is we use a graph index technology in knowledge base. So I summarize the open source timeline of GraphRAG. before August 2023, the Langchen called this technology means GraphQA, and someone gave a PR about to combine KG and AI together, after Llama Index gave the first GraphRAG system, the Microsoft proposed a paper which called From Local to Global, and gave their method about GraphRAG. And in this year, in May, we implement our GraphRAG system on LDBC AI framework of AntGroup, and we proposed a universal architecture to compatible vectors, text, and graph index. And in the follow months, Camel, AI, Neo4j, and Microsoft, and IIG Flow all give their own implementation of GraphRAG. In August, the AntGroup team gave the first GraphRAG survey of GraphRAG. The second part, I want to share the development of AntGroup GraphRAG. In the beginning, I want to compare the vector IG and the GraphRAG. We can see the whole workflow of IG is similar, but the most difference is the embedding model stage. In vector IG, we can see it used the embedding model to transform trunks to vectors because the storage is vector. Yeah, and in GraphRAG workflow, we use a LLM service to extract the triplets as a graph data and store them in graph store. So based on this similarity and the difference, I proposed the first universal architecture. In this graph, on the left part, we can see the vector store. And in the middle part, we can see the knowledge graph, which built on the graph store API. So we can integrate many graph systems to this framework. No matter vector store or knowledge graph, we call them all in one name, means the index store. This is the most different component in the IG. So we can use this architecture to emphasize the vector, text, and the graph store system. And we submitted this PR in DBGBT 0.5 and 0.6. And then when Microsoft released their GraphRAG system, I proposed a new PR about lightweight community summary to solve the QFS QA problems. And we gave some improvements, which including the trunk memory to discover the relationships between trunks, and use a graph community summary algorithm on our GraphDB systems like Leiden, Louvain, or other community discovery algorithm. And we add a third one, we add a document structured graph to the knowledge graph. And last, we use multi-root search to search the triplets information from graph store and the community summary information in the meta store. Okay. So the document graph I want to share is we want to preserve the complete information in the docs, because as we know, the triplets when extracted from the document test, some information was lost. So if some business want to use the whole information of the docs, they may want to use a document graph to enhance the knowledge graph. First one, we will keep the chapter and the section structure in the knowledge graph, and record the entity and the relationships to the source to combine the trunks and docs. So use this method, we can upgrade the query of triplets to triplets and plus trunk query. And at last, we compare the performance and the token consumption between DBGBT or AntGroup GraphRAG with Microsoft's method. And we use about 40% token consumptions. And the indexing time and the global search is better than the method in Microsoft's. The third part, I want to share the TestGCO method, which can enhance the semantic retrieval of GraphRAG. In my opinion, we can build many we can build a hybrid-driven search method, which can based on keyword-driven or vector-driven or text-driven. In the content in the content before is all belong to keyword-driven search, and now we are working on vector-driven search and text-driven search. The most workflow I want to share is the text-driven search. As we know, we can use the agent to transform user question to a text, and the text can be translated to a graph query language like GCO or Cipher. Why use this workflow? Because I have a assumption is that when you let somebody to describe the text to describe the GCO statement is difficult. So use agent as the to solve the NL2 test problems. Then use a fine-tuning model to translate the text to GCO is better. So the most difficulty in test GCO is the examples, because we don't have so much examples about GCO. So we proposed a ST-driven example generation. The main idea is to construct the ST of GCO statement, and we give a random value to assign the leaf code on the in the ST and generate answer statement like a match return and so on. This type. Okay, and when we have the answer, but we don't have the promote, so we use a generator to translate the ST to a promote template, and including many slots. And we can use the same method to assign the values to the promote template and generate a raw promote. But this promote is not readable, not very readable. So we can use a LLM to generalize this raw promote to a real promote. And at last, we combine the promote and answer together to build a example. Use this method, we fine tune the language model and get a prediction, get a 92% prediction accuracy. You can download the dataset and the model in DBGBT Hub repository. The last part I want to share the graph agents, which is the visible feature of GraphRAG IC. First, I want to reference Jerry Liu's opinion about which is IG's filter is agent. So graph IG's filter maybe graph agents. We can combine the AI system with graph. For example, we can use GraphRAG as a memory system, like to store the long-term memory or knowledge base. And we can use GOT or COT to implement the planning stage. For example, auto planner to decompose the task or build a workflow. And in the action, we can integrate graph tools like graph query tools, BI tools, DevOps tools, and so on. And all graph agents may generate a business graph solution to tell people how to use graph or how to use graph database. So in the next year, we will build a new repo which called TuGraph, or allies to TuGraph. Yeah, because our product's name is TuGraph. So this system may solve the problems between the user and the graph database. And the main feature may including this for the following points like language UI, auto planner, and graph+AI. And in the future, maybe we can use agent to profiling the database query or build AI ops and graph solutions. Okay, that's all contents I want to share. And if you have interest to build these systems including graph+AI, graph agents with me, you can contact to me with my email or on GitHub. Thank you, everyone.